Good afternoon, everyone. We are the third group and we will present metals. But before that, kindly let us first introduce ourselves. Next slide, please. I am Christine Joy Andrada Cañete, together with
Tracy Adrian Loberanes.
Shirley Pauline Manuel.
I'm Mindanya Carla May.
I am Pineda Bench Ashley.
I'm Sarino Gemma.
next slide. For the table of contents, it contains the introduction, kinds of metals, properties of metals, classification of metals, utilization of metals, example of mixed metals, and the summary. Next. Introduction. Metals. Metal is a term used to describe an element, material, or alloy that is typically solid, transparent, shiny, and has good electrical and thermal conductivity. Metal is used to make a wide range of items due to its strength and durability.
My topic is about the different kinds of metals according to the periodic table. Next slide, please. The metals shown in the periodic table are divided into groups, and these groups are called alkali metals, alkaline metals, transition metals, rare earth metals, poor metals, and semi-metals. Next slide, please. First is alkali metals and alkaline earth metals. Alkali metals are on the left side of the periodic table, and these are lithium, sodium, potassium, rubidium, cesium, and francium. While alkaline metals are beside the alkali metals, and these are beryllium, magnesium, calcium, strontium, strontium, barium, and radium. These metals are soft, have low melting points, and are highly reactive. These metals react readily with atmospheric oxygen and water vapor. These metals are named alkali and alkaline because when they react with water, they form alkalis. Alkalis are hydroxide compounds of these elements, such as sodium hydroxide and potassium hydroxide. Alkalis are very strong bases that are caustic. Lye, for example, is sodium hydroxide. Also, alkalis react with acids to form salts. Only beryllium does not react to water. So why does it in alkaline metals? Because it has some of the properties of the other metals in alkaline and only the reaction of beryllium with water does not exist. I know that you are curious about why these metals are separated into alkali metals and alkali metals in the periodic table. And that is because alkali metals have one valence electron in their atom outer shell, while alkaline metals have two valence electrons. Next slide, please. The next one is transition metals. Transition metals are the metals in the middle of periodic table, and these metals are most used in and known in the world. These elements are called transition metals because the electrons of their atoms have the transition to filling the d subshell or d sublevel orbital. Thus, the transition metals are also known as the d block elements. Transition metals have valence electrons in two shells instead of only one in their atoms. These metals are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, mercury, actinium, rutherfordium, dubnium, seaborgium, borium, hasmium, meitnerium, darmstadtium, ruthenium, copernicium. These metals are way more stronger than other metals because it possesses high density and high melting points and boiling points, but some has low melting points such as mercury, zinc, and cadmium. Next is rare earth metals. It can be seen at the bottom of the periodic table. Rare earth metals are necessary components of more than 200 products across a wide range of applications, especially high-tech consumer products such as cellular telephones, computer, hard drives, electric and hybrid vehicles, and flat-screen monitors and televisions. Significant defense applications include electronic displays, guidance systems, lasers and radar, and sonar systems. Although the amount of rare earth metals used in a product may not be significant part of the product by weight, value, or volume, the rare earth metals can be necessary for device to function. For example, magnets made of rare earth metals often represent only a small fraction of the total weight, but without them, the spindle motors and voice coils of desktops and laptops would not be possible. These metals are lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, scandium, and yttrium. Next slide, please. The next one is poor metals. It is located in the right of transition metals in the periodic table. Scientists can seem to agree on which elements should be included and what to call this group of metals. It can be poor metals, other metals, or post-transition metals. They normally have higher electronegativities than transition metals. Their melting points are lower, too. They are generally softer than other metals. They are called poor metals in part because that high electronegativity causes hints of covalent bonding effects not commonly observed in S-block metals or transition metals. These metals are aluminum, gallium, indium, thallium, tin, lead, bismuth, and polonium. Next slide, please. The last group is semimetals. It is also called metalloids. It is found beside four metals and it is in a zigzag line in the periodic table. Semimetals or metalloids are chemical elements that have properties of both metals and nonmetals. Metalloids are important semiconductors often used in computers and other electronic devices. Metalloids are used to make semiconductors, ceramics, polymers, and batteries. Metalloids tend to be shiny like metals but brittle like nonmetals. Because they are brittle, they may chip like glass or crumble to a powder if struck. Other physical properties of metalloids are more variable, including their boiling and melting points, although all metalloids exist as solid at room temperature. These semimetals are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and tungsten.
Next slide, please. For the properties of metals. Properties of metals. Metals have certain properties which include the following. Next slide. For the first one, malleability. Malleability is defined as a metal that deforms by compression. It may be hammered, rolled, or pressed into thin sheets. Hence, this assertion was proved since the metal slowly deforms into any shape by doing this procedure. Gold, iron, aluminum, copper, lead, and silver are the most common malleable metals. Next. Second, ductility. In general, ductility is the process through which metals may be stretched or bent without being damaged. The most ductile element is gold, which can create or be pulled into wires up to 2 km long from just 1 gram of it. In structural constructions, ductile permits structures to flex and deform to a certain amount without dislocating. It is vital in structural structures such as bridges for safety. Although a substance can be both ductile and malleable, which means it can form and be dragged into wires, they are not the same thing. Metals are malleable and ductile due to the similar movement of outer electrons. This movement is also responsible for the ability of metal wires to transport electric current. A gold sheet can be rolled into thin sheets of gold leaf or pulled into a wire. Copper may also be pulled into a wire, hammered into sheets and shaped. Metals, on the other hand, are not consistently ductile and malleable, such as aluminum, which may be formed and shaped but cannot be pulled into a wire. But according to our findings, aluminum can be pulled into wire but is not as strong as copper. Next slide, please. For the third one, good conductors of heat and electricity. When there are free electrons available and the molecules of metals are in close proximity to one another, metals can conduct both electricity and heat. The electrons are not bound to any atom and can freely travel throughout the metal. When a metal is heated, free electrons near the heat source are likewise heated. As a result, they can move quicker and go through the metal, clashing with other atoms and electrons, causing them to naturally vibrate, resulting in heat moving through the metal rapidly. Metals require a power source to overcome their resistance and allow an electric current to pass through them. Copper is an excellent electrical conductor because the lower the amount of resistivity, the greater electrical conductivity the metal has. And it is used to manufacture the cooling coils of air conditioners and refrigerators. Cooking utensils are composed of heat conducting metals such as copper, aluminum, and stainless steel. Good conductors are also employed in the construction of the bases of electric irons, solar heating pipes, and boilers used in power plants and factories. Next. For the fourth one, last truth. This is the property that describes an element's capacity to shine. It occurs when a light source is strike the surface of rocks, elements, or substances and reflects, giving it a gleaming and sparkling look. In addition, the existence of free electrons in metals causes light impacting on them to be reflected back. For example, jewelries are generally made of gold and silver, and we all know how shiny gold and silver are. Another example is the mirror. We all know that mirrors usually reflect light when it goes through them. The mirror is made of aluminum and silver, both of which have lustrous finish. Next slide. Hard or hardness. Hard materials are solid by nature, while some are hard by nature, exhibiting ductility, malleability, and sonority. Metals are hard, which means they will not easily cut or shatter. The hardness of ductility of a material influence how well it can sustain impact without cracking. Metals cannot be deformed or reshaped due to their hardness. However, they may be crushed. Metals such as aluminum, copper, iron, and others can be found in hard materials. Next, solid at room temperature. When a metal has both high thermal conductivity, which is the capacity to conduct heat, and high electrical conductivity, which is the ability to conduct a significant quantity of electrical current, it is considered solid at room temperature. Except for mercury, which has a low melting point, poor electrical and thermal conductivity, and does not form diatomic mercury molecules in the gas phase, all metals are solid at room temperature. Next, high density. A metal with high density has a high mass for the size or volume that it occupies. Metals have high density because their atoms are packed very closely, together in a limited area. Temperature changes have little effect on the substance density, while materials do expand when heated. The size change is very small. Next, sonorous. This is the property of materials that, when heat, make deep sounds, such as copper, aluminum, steel, bronze, tin, iron, silver, and so on. Metals naturally electropositive. When a metal is struck, the electron cloud in the metal quickly moves. This movement of electron emits relatively little energy, which may be easily transported in the form of sound waves. And this phenomenon is known as metal elasticity. To be sonorous, A metal must be elastic with regard to electron mobility. Next. And for the last property of metals that we prepared, number 9, have high melting and boiling point. Due to the tight metallic bonds found throughout their massive structures, metals have high melting and boiling points. The temperature where a substance, solid, and liquid phases are in equilibrium is known as its melting point. A substance boiling point is determined by the temperature at which its vapor pressure matches the external pressure. Next slide.
The three classifications of metal: the ferrous metals, non-ferrous metals. Next. And the pure metals. Next. So first is the ferrous metal. As we can see in the presentation, there are advantages and disadvantages of this metal. Ferrous metal contains iron and it is commonly used in large structures because it has strength properties and it is durable. It is also used in producing electrical and motorized machinery because it contains magnetic quality. Ferrous metal heavier than non-ferrous metals since it has iron content. Ferrous metal is used in many different fields, like in the construction of building to the creation of the appliances, so it is being mass-produced to satisfy the demand of the customers. And the disadvantages of ferrous metal is it is prone in rusting, especially in outdoors because of the climate change, and it contains a lot of iron, so this type of metal is not recommended in roofing. Next. The example are wrought iron. Wrought iron is very strong. It is used in fences, gates, railings, and grills. Second is the carbon steel, which is durable, strong, and shock resistant. Next. Non-ferrous metal. Non-ferrous metal has no content of iron, so it is resistant in rust and it is lightweight. They are perfect for outdoors like roofing and gutters, since it doesn't have iron, and it is not magnetic, and the disadvantage of this is high cost, because this kind of metal has low resources, unlike the ferrous metal. It also have limited strength capabilities. Next. Example is the copper. Copper is a ductile, malleable, and remarkably effective at transferring both heat and electricity. Second is the aluminum. It has very low weight and also formable, bendable, and welded. Next. Pure metals. Pure metals are the metals that doesn't have any mixture. The purity of this metal is 99.99%, and the disadvantage of this are limited in usefulness because of its soft and brittle.
Utilization of metals. Next. There are many metals found in periodic table, and some of these metals' qualities, as well as their classification, are influenced by their atomic structures, which also impacts how the metals are utilized. Steel. Steel is commonly used in construction because it is strong, durable, and able to withstand the stresses of the construction process. Steel is commonly used for building, constructing structures, bridges, and other structures. Building frames, beams, and columns are made from it, along with other structural components, including brackets, connector, and fastener. There are three types of steel. Carbon steel. Carbon steel is one of the most widely utilized materials in industrial application, and it is an alloy of iron and carbon. Because of its strength, durability, versatility, and affordability, it can be used in a variety of applications such as in pipes, I-beams, channels, and other structural shapes, as well as in the bodies of automobiles and bridges. Next is alloy steel. Alloy steel can be used in a wide variety of application depending on what elements are added. Some alloy steels are utilized in the production of pipes, especially those for energy-related uses. Low alloy steel and high alloy steel are the two main divisions of alloy steels. The category that alloy steels belong to largely determine how they are used. Low alloy steel is used in ships, pipelines, pressure vessels, oil drilling platforms, military vehicles, and construction equipment. And it is used because of its strength, machinability, and affordability, while high alloy steel is expensive to produce and hard to work with, but they are used for automobile applications, chemical processing, and power generation equipment due to their strength, toughness, and corrosion resistance. The difference between alloy and carbon steel pipe is that alloy steel pipe are used for high temperature services such as heater tube because carbon steel pipes have their limitation compared to alloy steel where another alloying element is added that affected the properties of materials. The last one is stainless steel. Stainless steel is commonly used because it is resistant to rust and corrosion in food accessories, bridges, shipbuilding, storage tanks, and power generation plant that requires material that endure high temperature and extreme pressure where it is utilized in heat exchanger, reactor tanks, pressure tubes, transformer, enclosures, and more. Storage tank use stainless steel because it doesn't add any flavor or smell to food and water like it does not add rusty flavor to water which is another advantage of stainless steel. Bridges are used in engineering structures like bridges because of their great strength and corrosion resistant properties. Stainless steel can be found in modern bridges around the world. um, Stainless steel is an ideal material to use in bridges. It is equally useful for both large and small bridges thanks to its durability and cost effectiveness. Next slide, please. Aluminum. Aluminum is utilized in the construction industry and is the one most widely specified metal in buildings after steel. It is used in all construction sectors from commercial buildings to domestic dwellings because aluminum is popular for being lightweight, makes utilized for electric wires, food packaging, and cooking pots. It is also used for window frames, doorknobs, and other decorative architectural components. Aluminum tubes are used because it is lightweight, corrosion resistant, and commonly used for both plumbing and construction application. They are also suited to structural application and high pressure fluid flow. And aluminum wiring is used because it is much lighter than copper and it is easier to install, but there are many disadvantages and additional requirements should be considered in aluminum wiring such as aluminum wiring has low current conductivity compared to copper and greater but they have greater thermal expansion and contraction compared to copper which will this may impact the integrity of connections and in severe cases could result in fires. As a result, aluminum cables require more regular maintenance or inspection to ensure connections have not loosened over time. Next slide, please. Copper Copper is used in electrical application because it has high conductivity compared to aluminum. Copper is the second most conductive material in the world after silver due to its excellent physical properties and the use in almost every electrical application. Tungsten. Tungsten is naturally resistant to corrosion and chemicals due to its tensile strength. Tungsten is used in the aerospace and automotive industries, and tungsten alloys are utilized for components such as rocket engine nozzles, turbine blades, high-speed steel, Hastelloy, satellite, and other alloys are made with it. Tungsten is used in engine nozzles because of its hardness and high temperature application. Next slide, please.
Continuation of utilization of metals. Wrought iron. Wrought iron is a soft material produced from semi-fused pure iron surrounded by slag. It contains less than 0.1% carbon and 1 to 2% slag. In contemporary usage, wrought iron is a metal that is worked often on anvil using the skills of a blacksmith. The metal is heated and forged and hammered to shape. It is soft, ductile, magnetic, and has high elasticity and tensile strength. It can be heated and reheated and work into various shapes. Although wrought iron exhibits properties that are not found in other forms of ferrous metal, it lacks the carbon content necessary for hardening through heat treatment. Wrought iron is highly used for decorative items like fences, gates, railings, balconies, porches, canopies, roof crestings, grills, hardware nails, iron clamps, lamps, structural members and tension, I, H, and other beams, etc. Next slide, please. Magnesium is used to produce products that benefit from being lightweight, such as car seats, luggage, laptops, cameras, and power tools. It is also added to molten iron and steel to remove sulfur. As magnesium ignites easily in air and burns with a bright light, it is often used in stairs, fireworks, and sparklers. Next, please go. Bronze. Bronze is used in the construction of sculptures, musical instruments, and medals, and in this industrial applications such as bushings and bearings, where its low metal-on-metal friction is an advantage. Bronze also has a nautical application because of its resistance to corrosion. Bronze is used in architecture for structural and design elements, for bearings because of its friction properties, and as phosphor bronze in musical instruments, electrical contacts, and ship propellers. Aluminum bronze is used to make machines and tools, and some bearings. Next slide. Zinc. Most zinc is used to galvanize other metals, such as iron, to prevent rusting. Galvanized steel is used for car bodies, street lampposts, safety barriers, and suspension bridges. Large quantities of zincs are used to produce die castings, which are important in the automobile and electrical and hardware industry. Die casting is a metal casting process that involves feeding molten non-ferrous metals into dies under high pressure and high speed to rapidly create molded products. The main materials used in die casting are alloys of aluminum, magnesium, and zinc. Next slide. Titanium property. Titanium is typically used for airplane parts and fasteners. These same properties make titanium useful for production of gas turbines and engines, while it is also used for other parts such as the compressor, blades, casings, engine cowlings, and heat shields. Titanium properties, which are a combination of high strength and stiffness, toughness, low density, and good corrosion resistance, provide various titanium alloys at a very elevated temperature. Uh, Next slide. Lead. Lead is still used for car batteries, pigments, ammunition, cable sheetings, weight for lifting, weight belts for diving, lead crystal glass, radiation protectors, and some solders. It is often used to store corrosive liquids. A large proportion of lead of the a large proportion of lead used today serves the automobile industry in components such as storage batteries, radiators, and solders for joints. Lead is an important part of chemical tank liners and one of radiational shields in telephone and power cable conduit. Next slide. Cobalt. Cobalt is used in many alloys. Superalloys for parts in gas turbines, aircraft engines, corrosion-resistant alloys, high-speed steels, and cemented carbides. In magnets and magnetic recording media as catalysts for the petroleum and chemical industries as drying agents for paints and inks. Cobalt is used to make airbags in automobiles, catalysts for the petroleum and chemical industry, cemented carbides, and diamond tools. Its properties has high corrosion resistance and wear resistance, drying agent for paints, varnishes, and inks, dyes and pigments, ground toast, and for porcelain and enamel high-speed steels. Next slide. Nickel. Nickel-containing products play an important role in our daily lives. Compared with other materials, nickel-containing products possesses better corrosion resistance, greater toughness, more strength at high and low temperatures, and a range of special magnetic and electronic properties. Therefore, most nickel production is used for other elements, coating, batteries, and some other uses such as kitchenwares, mobile phones, medical equipment, transport, buildings, power generation, and jewelries. Next. Silicon is used in construction materials, making transistors and computer chips and solar cells as waterproofing system as silicons. The flexible rubber plastic has high heat resistance and low toxicity, making an ideal sealant choice for plumbing pipes, aquariums, ships, and other metal fabrication projects that require water seals.
Examples of mixed metals. So before we go to the example of mixed metals, let us define first what is mixed metals. Mixed metals are a class of man-made materials created by fusing together two or more metals or by fusing metals with one or more non-metallic elements to increase the primary metal's strength, durability, and versatility. So the first example of mixed metals is bronze. Bronze was the first alloy to be found. It is made of 85 to 88% copper and 12 to 12.5% tin and small amounts of other metals like aluminum, manganese, zinc, or nickel. Copper's properties are improved with this mixture. So next one, steel. So steel is an iron metal that typically includes carbon at a percentage of 1 and occasionally includes manganese, nickel, and other elements. Steel is manufactured because of its desirable qualities as a strong, durable, and corrosion-resistant material. So the four types of steel. The first one is carbon steel. Carbon steel is defined as steel containing up to 2.1% carbon by weight. The second one is stainless steel, also known as inox steel, calls for a minimum of 11% chromium by mass and a maximum of 1.2% carbon by mass. Tool steel is a high-quality carbon and alloy steel, typically between 0.5% and 1.5% carbon. It is needed to make the instrument that shape other materials, so it is a byproduct of the manufacturing process. Alloy steel. Alloy steel is produced by combining carbon steel with one or more alloying metals such as manganese, silicon, nickel, titanium, copper, chromium, and aluminum. Brass. In comparison to bronze, which is a combination of copper and tin, brass is an alloy of copper and zinc with various other elements such as arsenic, lead, phosphorus, aluminum, manganese, and silicon. In order to better its electrical and mechanical characteristic, this alloy is manufactured. There are four types of brass. The first one is alpha brass. Alpha brass has a copper content of over 65% and a zinc content of under 35%. It is a single-phase material that is suitable for welding, pressing, forging, and other related processes due to its malleability and ductility. The second one is alpha beta brass, which consists of 55 to 65% copper and 35 to 45% zinc. Is the second type of brass, often referred to by its alternate name bidirectional brass. This metal can withstand high temperatures without deteriorating since it can transform between alpha and beta states. It outperforms alpha brass in terms of strength. Beta brass, which contains between 50 and 55% copper and 45 and 50% zinc, is the third type of brass. Due to its beta composition, it outperforms both alpha and alpha beta brass in terms of strength to manipulate it. Heat is required. Gamma brass contains 33% to 39% copper and 61% to 67% zinc. Last one is the white brass. It's made up of more than 50% zinc and less than 50% copper. It's not golden like real gold and it's brittle and looks more like silver. Alnico. Alnico is an aluminum cobalt metal. The letters Al, Ni, and Co make up the moniker aluminum, nickel, and cobalt. In terms of magnetic strength, alnico is regarded as third only to neodymium and samarium cobalt. Solder. A solder is a molten metal alloy that is used to firmly join other metal components. It is primarily made up of tin and lead, with small amounts of other elements. Cast iron. Cast iron is an iron compound that consists of and carbon, 2 to 4%, and silicon, trace amounts. Cast iron has a high number of desirable properties, including a low melting point, castability, machinability, excellent fluidity, resistance to deformation, and wear resistance. Sterling silver. Sterling silver contains 92.5% pure silver and 7.5% copper or another element. Tarnish appears rapidly on silver. Therefore, sterling silver is an alloy made of copper and other metals that is combined with silver to prevent it from tarnishing. Silver's durability and toughness are also enhanced by this process. White gold. In order to create white gold, gold is typically combined with another white metal, such as silver, nickel, or palladium. Rose gold. Rose gold. The copper in rose gold makes it look pink. This alloy, also known as Russian gold, was first used in that country in the 18th century. Pink gold and crimson gold are two other names for rose gold. Woods metal. Woods metal is an amalgam that by weight features 50% bismuth, 26.70% lead, 13.33% tin, and 10% cadmium. Barnabas Wood created the metal nichrome. Alloys of nickel, chromium, and iron are what make up nichrome. As a resistance cable, this alloy is extensive use. It has a high melting point, is inexpensive to produce, is strong and ductile, and is not easily oxidized. Nichrome's useful qualities make it a popular choice for use in heating elements. Summary. Everything I described is a case of mixed metals. Those are just a few examples of alloys, but hopefully you can see how crucial they are to our everyday existence. The fact that they have so many applications in different fields also contributes to their popularity. Aircraft, factories, medicinal devices, factories, and the military all use them. Alloys such as aluminum, nickel, copper, stainless steel, and titanium are used in the manufacturing of equipment and automobiles. Moreover, we can manipulate characteristics like hardness and reactivity to create new compounds with practical applications.
The different kinds of metals in the periodic table are divided into 6 groups. First and second are alkali and alkaline metals. They both react in water and form alkalis, but the difference between them is alkali has one valence electron, while alkaline has two valence electrons in their atom's outer shell. Third is transition metals, which are the metals that we usually see every day that is sturdy and hard. Fourth is the rare earth metals, which are hard to get and mostly used in electronics. Fifth is the poor metal, which are softer metals and have a low melting point and higher electronegativities than transition metals. And the last one is semi-metals, which have the power of both metal and non-metals. Metals have a wide varieties of properties, such as malleability. They can be hammered into thin sheets. Ductility. They can be drawn into wire. Good thermal and electrical conductivity. Lustrous. They can shine when a light source strikes them. Hardness. They are not easy to cut. Solid at room temperature. They have high thermal and electrical conductivity, high density, and sonorous. They can produce deep sounds when hit.
The three categories of metal classification each offer advantage and disadvantages as well as strengths and limitations. In addition to being used in buildings, both ferrous and non-ferrous metals can be used in roofs and other metal using structures of home, buildings, and other structures. Non-ferrous metal is resistant to rust because it lacks iron, whereas ferrous metal is prone to rust because it contains a lot of iron. All scrap metal should be recycled because it takes less energy to extract natural resources and reduces the quantity of garbage that end up in landfills. There are many kinds of metal found in the periodic of elements metals. Qualities as well as their classifications are influenced by their atomic structure, which also impacts how the metal utilized. There are many applications of metal that is used in daily life, also in construction and structural application. We utilize different kinds of metal for its different and unique properties. Every kind of metal has its own set of properties that engineers and builders could used to create an amazing innovating creations.